Hi there, this is a quick video about this strange module here that I just bought from eBay. It obviously came from a USB power bank of sorts. I bought it because I'm on the lookout for a USB power supply that allows simultaneously charging while still delivering power to the load. I want to power a Raspberry Pi Zero to basically run continuously from a battery while occasionally topping it up with a charger. The module under the name of Circuit Board Module DIY Power Bank New came from the seller jpsurfshop. It looks slightly different to the one I got, but it has the same chopped off wires and the liberally applied hot snot. I wonder whether this is really new or has been recycled from some power bank. The strange thing is there's no on-board connectors. Instead, they were obviously using cables. It must be some strange looking power bank where this came from. In any case, the listing has no additional data of any kind. Well, the first action is to get rid of the hot snot. To help with that, I'm heating it moderately with my hot air gun set to 130 degrees Celsius, but the snot seems very resilient. And after half an hour of heating and poking and pulling, I decided it was good enough. I did manage to get quite a lot off, but by no means all. Time for a closer look. On the left side we have two cables marked ground and V-in, obviously the charge input. The 8-pin chip you see is the unit power UM3801, which contains two MOSFETs, one being N-channel and the other P-channel. The two transistors marked Q1A and Q1B on the right of the charge input are marked AFZW15, but I did not manage to find a datasheet for them. The two black wires lead to a thermistor which was obviously once glued to the batteries. On the right we have the four wires for a standard USB port. This is obviously the output. The 6-pin chip Q3 on the left of it is an 8205, a dual N-channel MOSFET, probably to turn the output off and on and for overcurrent protection, judging by the shunt resistor there. The big chip is an NTMP2012-1, more about that in a moment. On the upper side of the board we have two thick wire stumps marked P- and P+, that should be the battery connection. There are four LEDs in some kind of foam cover to prevent light from one to leak to the next if this board was mounted against a transparent front panel of sorts. And then there is a single button. Back to the brains, the big chip. The little 3-pin SOT23 on the left of it is the 431 voltage reference, by the way. I have not been able to find a datasheet for the NTMP2012-1, but a schematic using it that looks quite similar. The obvious difference are the number of LEDs. But it does have a pretty similar input and output circuit. And the rest looks quite similar too. For the first test, I hooked it up to three 18650 that are wired in parallel. The multimeter shows the battery current. The input of the module is connected to a bench power supply, but turned off at the moment, and the output goes via the red USB tester to a USB light. Plugging the load out and then in again does nothing. This module obviously does not sense load and auto starts. That's not very convenient for my plans. Pressing the button does the trick. The four charge indicators come on, and so does the USB light on the USB tester output. We have 5.1 volts and about 240 milliamps, while the battery current is close to minus 400 milliamps because it's discharging. When I turn the power supply connected to the input on, the output voltage drops slightly and the battery current reverses to about plus 240 milliamps because it's now charging. So far so good. The Raspberry Pi should be able to run with a slightly reduced voltage. But oh dear, when I turn the charge voltage off, the module shuts down too. That's not very nice and basically rules it out for my project. Oh well, while I'm at it, I might as well do some more tests. In this one, the input voltage is again turned off. What happens if I remove the load after it was running? I shortened that wait a bit for you, but exactly 30 seconds after removing the load, the module turns off. And when you kickstart it without load, same thing, 30 seconds later it turns off. In this test, again without input voltage, I kickstart the module with the USB light as load, and the battery discharge current is, as expected, minus 400 milliamps or so. What happens if I start heating the thermistor with my hot air gun set to its lowest setting of 100 degrees Celsius? The module turns off and the charge indicator LED blink to alert the user of the battery over temperature. That's working nicely. After taking the hot air gun away for a few seconds, the thermistor has cooled sufficiently for the module to automatically spring back to life. You may have noticed from the close-up or the schematic that the data bus lines of the USB output are not just shortened together like in many cheap chargers. They are connected to two voltage dividers to signal the allowed charge current to older phones and MP3 players of USB 1 and USB 2 vintage. Instead of calculating it from the resistors, let's measure it instead. With the negative lead of the multimeter connected to ground, D plus measures about 2 volts and D minus is just shy of 2.8 volts. According to Wikipedia, those values match an old Apple standard, allowing the connected device to draw up to 1 amp of current from the port. To find out if that is true, I connected my electronic load instead of a USB light. We start with 200 milliamps and increment in 100 milliamp steps. Well, 1 amp is certainly no problem. 1.1 amp still okay. 1.2 amps, the volts start to sag a little. 1.3 amp and it shuts down. Reducing to 1.2 amp and it tries again to restart. Reducing to 1 amp and it's happy. So this module is good for 1 amp, which would be more than enough for my purpose. Last test, how does it handle low battery? In this test, the battery is replaced by a power supply to allow me to vary the voltage, which is shown by the multimeter. I turn on the electronic load to draw 200 milliamps. At 4 volts or so battery voltage, all 4 charge indicators are on. At 3.67 volts, only 3 charge indicators are remaining. 3.58 volts, that's just 100 millivolts less, only 2 indicators remain lit. 3.47 volts, another 100 millivolt less, and we are down to the last indicator. 3.17 volts, and now the last indicator starts blinking. And dipping just below that, it shuts off. Basically 3 volts is the low battery cutoff voltage limit. That's quite conservative, but better safe than sorry. To sum up, despite being apparently ripped out of something, the module itself is quite nice and the thermal protection a bonus. A 1 amp current limit is reasonable for powering small projects using Arduino or Raspberry Pi Zero. Against that, it does not sense load and must be manually kickstarted, which is rather inconvenient for these users. It supports charging with a load connected, but unfortunately spoils it all by turning off when the charge input is disconnected. Not good if you wanted to keep something running continuously. So while not an answer for my immediate problem, it may come handy for use in other projects. Thanks for watching.